All right, welcome back, everybody playing along at home. So this is going to be we got the warm up going over some elimination. We're going to do go over the homework, and then we have the second day of section 6.3. So as I was just explaining to my in-person class, we got section 6.3 to finish up today, section 6.4 to do tomorrow. Practice test day is going to be on Wednesday. We're going to go over it on Thursday, and then we're going to have a test on Friday, and then you're going to have your exam review packet as homework over the weekend, Friday to Monday and Tuesday. Okay, and then we'll next week. Monday, Tuesday, Wednesday, review, exam, Thursday, Friday. All right, so let's get started here. Now, why would I say that number 11 is set up for elimination? Why would I say that number 11 is set up for elimination? Well,
it's because the y's are exactly opposite.
Good. It's because the y values are opposites. We have a positive 1 and a negative 1. Does everybody see that? When you have that, that's what's called setup for elimination. So what do I do at that point? Well, I just add the two equations together. Right? I don't need to multiply by anything in this case. I just add these two equations together, straight up as they are. Now, that means I have a negative x and a positive 2x. Okay, negative 1 plus 2 is positive 1, or just x. And then the negative 1 plus 0 is negative 1. Wow. So this problem, you really don't have like anything to solve right there. Negative 1 plus 2 is a positive 1. Negative 1 plus 0 is a negative 1. Okay, so that means x is negative 1. Let's plug it back into the bottom. 2 times negative 1 minus y is 0. So negative 2 minus y is 0. We would normally get everything away from the y, but I think this might be easier just to move the y over to the other side. So negative 2 is equal to y. So that means my point is negative 1 comma negative 2. Okay. Any questions on number 11? All right. Now, is number 14 set up? Not yet. It's very close, right? It's very close, but it looks like I'm going to have to multiply. Okay, what do I have to do? What do I have to do then? What's that? Negative 1. Which one you want to do? Top or bottom equation? Doesn't matter. Top. He's going to multiply the top equation by negative 1. The reason being is when I do this, it gets my x value to be negative x. Now this is going to be a positive. Everything else gets kind of carried along for the ride. Right? I don't really care what happens to my y and my constant on the other side, just as long as it, we multiply that negative in. It'll come out in the wash. Now, the second equation just stays exactly the same. Do not change the second equation because now, look at my x's. One's negative 1, one's positive 1. If I add those together, they will cancel each other out. So this is a negative y. 1 plus negative 2 is a negative 1. And then a positive 6 here. Finish it off, divide by negative 1. I get y is equal to negative 6. Joey, what do you want to go into? Top or bottom equation? Top. So let's go into original top. This is x minus a negative 6 is equal to 4. So let's just say x plus 6 is equal to 4. Subtract the 6. We get x is equal to negative 2. So my solution is negative 2 comma negative 6. Questions on 14. All right, 17. Now, I obviously have to multiply. I have to multiply by something. Nothing is even close to being the opposite value, right? Nothing's even close to it. So that means that I have to multiply an equation. Okay, which equation am I going to multiply and by how much? Which equation am I going to multiply and by how much? Elena? Good. I would multiply the first equation by 3. What's the other option? What's the other option to multiply?
5.
Close. Negative 5, right. The other option is to try to eliminate with x's. I would want this to be a negative 5 right there. So I'd have to multiply by negative 5. But we said, and this is the better option in my opinion, I want to multiply by 3 because I don't have to multiply by any negatives. We multiply by negatives and our life gets a little bit more difficult. So let's multiply this first equation by 3. That gives me a 3x minus 3y is equal to negative 9. Keep your bottom equation exactly how it is. 5x plus 3y is equal to 1. And look at that. Look at my y values, all nicely lined up. Opposites, they'll cancel each other out. Negative 3y, positive 3y, gone. 3 plus 5 is 8. Negative 1 plus 9, or sorry, negative 9 plus 1 is a negative 8. I divide by 8. So x is equal to negative 1. I plug negative 1 back in. Elena, which equation you want to go into, top or bottom? Okay, let's go into bottom. 5 times negative 1 plus 3y is equal to 1. So this is a negative 5. I add the 5 over to the other side, which means I get a 3y. What do you think about 6? 3y is equal to 6. Divide by 3. Y is 2. So that means my equation, or my coordinate is negative 1 comma 2. And that's my answer. Okay, how do we feel about that solving by elimination?
Terrible.
What's that?
Terrible.
Terrible?
I just did terrible.
Terrible. Well, good thing we're doing a second day on it today, right? Here's what I got. All of the answers right up there. Please check your homework. Check your answers. We could go over one of these. We could go over 3 of these. We could go over all of these if we really wanted to. I know the work's not there. I will show the work. Okay? But you have to ask me about it. So go ahead and check your answers. Ooh, tomorrow's going to be a hat day. Tuesday, December, hat day. Donations collected in third period classes. I think it's just $1.
I don't think.
I thought you were
Bro.
I love wearing hats. I wear hats like if you see me out in the world, not in this building, I'm in a hat. Like I live in a hat.
I had like a hat.
It's so weird. People that know me outside of here, they're like, when they see me without a hat on, they're like, you look weird. It's like I got hats in my closet over here. Just in case in the odd chance there's a hot day that I'll miss. Right? I got a turkey.
That's a little bit.
Got a my golden bear hat. They don't?
That's pretty neat.
Who is anybody know golden bear? No, well, that is kind of true. But there's a golfer, golden bear. Jack Nicklaus? No? That's a boy. Why do I have so many extension cords tonight? Got like 3 extension cords.
That's not my hair.
All right, questions. What do we want to go over here? Got to go over at least one. Somebody tell me, at least one. Somebody volunteer for me. Number 2? Number 2. Now, number 2 is already set up for elimination, right? Let me do this, and then I'll do this, and then we can do that. We'll go there.
We do 6 next.
Sure.
3, 4, please.
Okay.
And then 3.
And then the rest of them, 3. So I'm going to add these 2 equations together, right? I'm going to add these 2 equations together. And I don't have to multiply by anything because look at the y values. The y values are already set up to eliminate. Positive y and negative y. So x plus x is 2x. 12 plus 2 is 14. Divide by 2. X is 7. And let's go back in. Let's go back into the top. I don't know. 7 plus y is 12. Subtract the 7. Y is 5. 7 comma 5. We good with 2? Questions on 2? Okay, what was the next one? 4, did I hear?
6.
Oh, 6, I'm sorry.
6 and 4.
Let's do 6 first, and then we'll hit 4. This cough is not going to go away. All right. Now, it looks so tempting to just try to add these together right now. So tempting. Resist the temptation. You cannot eliminate yet. You cannot eliminate. What do I have to do?
Multiply by -1.
Which one? Top or bottom?
Top.
Okay, let's multiply the top by -1. We understand that we could multiply the bottom by -1, right? And that would get the same thing. Positive 5x. Make sure you do everything too. Very common mistake is when people are coming up and be like, I don't know what I did wrong. Tell me what I did wrong. You know where I look very first? Right here. Right there. Did you make that a -11? Did you multiply from here over to the constant? When you're multiplying, the tendency is to forget to do the constant on the far right side. All right, bottom remains the same. -5x plus 3y is 19. So there's a y there. And then we add down. The x's cancel. -7 plus 3 is a -4. -11 plus 19 is a +8. Divide by -4. Y is -2. Let's go back into the bottom. I don't know. -5x plus 3 times -2 is 19. So -5x minus 6. Add the 6. -5x is 25. -5, -2. There's my answer. Dave, wake up. Thank you. Questions on 6? Okay, let's walk through 4. All right. Now, for 4, again, this is one of those ones where it's very tempting to try to just add these together right away. I can't do that. I've got to multiply by a negative. Okay. So which equation do we want to multiply by a negative? Bottom? Let's do it. So multiply the bottom equation by -1. That means original top stays. X minus 10y is equal to 60. The bottom becomes a -x, a -14, and a -12. And now I add these two equations together. My x's cancel, my y's become a -24, and 60 minus 12, that's 48. We divide by -24, so y is -2. We plug it back in. Let's go back to my original top. X minus 10 times -2 is 60. Again, it doesn't matter where it goes back into. X plus 20 is 60. So X is 40. Don't be afraid of big numbers. They won't bite. Joey.
We're going to have different signs to it. Like add them all.
Yes. That's why we had to multiply by a negative here. We had to multiply by a -1 so that we achieved the whole different sign thing.
I thought you had a different sign, like 10y plus 14y.
No, see, at this point, like, and that's what a very common mistake is. You don't really care what's happening with the y's. if you're trying to eliminate with x's, the y's will work themselves out. You only care about getting one set to go away. The other one will get you your next solution. Does that make sense? You kind of just let that one be. It kind of carries along for the ride. Okay. Any other questions on the homework that we want to talk through or go over? All right. Let's take a look here at today's notes. Let me give you the guided notes. I'm really sorry. We got a lot of guided notes to go through today. I'm really sorry. It's 3 problems. I'm so sorry.
Wow,
I know.
So much.
I just feel awful. On Monday, you guys are gonna just be so bogged down with guided notes.
The sarcasm is strong in this class.
What are you gonna say? We got a 9. 9? Yeah. So you 9. That has to be a mistake. You gotta skip her. That's not true. There's no way you can have 9. Are you gonna start one in the morning and night? 9.
Like, totally
No, you might want to check on that. Sure. Yeah,
Yeah, 9. Wait, let me see what
It's right next to the grade line. So like, I bet he accidentally wrote grade 9.
Yeah, he had to.
Just so get that taken care of. I've never heard of getting 9 detention. Maybe they're just like setting an example, like, you better not miss LOP. We will give you 9 detention. Next time it's gonna be 20. All right. So, here we go. So section 6.3, day 2, solving systems by elimination. Let me ask you this. Is this one set up for elimination as it is right now? No. It's not. Is there a way to multiply one of the equations to make it look like the other? Multiply. Only multiply. The only operation I can do is multiply. Like, here's what I'm thinking, guys. Take a look up here. Liam, open your eyes. There we go. It's hard to look up here if your eyes are closed. Is there anything to multiply 2 by, any whole number to multiply 2 by to make it look like -3? No. Is there anything to multiply -4 by to make it look like 5? No. Everything would be like a fraction to multiply it by it, right? So there's nothing to multiply by. Okay? Just one equation. So here's what we have to do. In this case, I have to multiply both of the equations. Okay? And this is the hardest type of elimination problem, where you have to multiply both of the equations to get them to match up. Okay, let me ask you this question then. If I were wanting to eliminate with the x's, what number are they closest to? Like, what number could I make them pretty easily? 6, right? 6 and -6, right? So now, why is 6 a special number between 2 and 3? Because it's my LCM. It's my least common multiple. Okay, you're looking for the least common multiple between those two coefficients. That's what you're trying to make it. Okay, so how do we make 2 look like 6? What do we multiply by? And I can't just do one piece of it. I've got to do the entire thing. How do I make 3? Well, and actually, this is going to work out really nicely because the top one's going to be a +6. The bottom one is already negative. So how do I make it look like -6? Multiply by
2.
Multiply by 2. And I got to multiply the entire equation. So let's do that. The top equation becomes, okay, let's multiply by 3. 6x 15y. Okay, 26 times 3. Well, 25 times 3 would be 75. So 26 times 3 would be 78. And then we multiply them with the 2 on the bottom. 2 times negative 3x is a negative 6x, which makes sense because I want that to line up, right? 2 times negative 4 is a negative 8. Again, I don't really care what's happening with my y's. Everything else is just kind of getting taken along for the ride. Don't drop negatives. Guys, the biggest issue I always see is sign mistakes. Dropping negatives. Not being careful. Not being organized. Our x's now will cancel. Our y's become a positive 7y. 15 minus 8, or 15 plus negative 8, is a 7. 78 plus a negative 50, or 78 minus 50, is 28. Okay, so now this becomes like any other elimination problem that's kind of set up. It's already set up so it's easier. We just divide by 7 here, and I get a 4. Okay, Liam, which equation do we want to go into? Top or bottom? Top. Let's go back into the original top. Don't go into the top that you've already multiplied by. Those numbers are just bigger. Right? It's the same equation, just bigger. Go back to your original. 2x plus 5 times 4 is 26. So 2x plus 20 is equal to 26. I subtract the 20 to get 6. X is 3. So that means, again, don't lose sight of my end goal, to get the point where the 2 lines will cross. Now, if I would have gone back to the beginning and had chosen, don't go on to the next one yet, please, 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 listen to me. If I would have gone back to the beginning and said, well, what if I wanted to do this problem differently? What if I had said, let me clone this and move it down a little bit. What if I had said, okay, I want to eliminate the y values now? What number would I try to get them to? 20. Positive and negative 20. It's good that the signs are already different. Then one of them doesn't have to be negative. So look for ones that have different signs if I'm going to have to multiply both equations. So I would multiply the top by 4 and the bottom by 5. I don't care what happens to the x's. The x's get carried along for the ride. Okay? So let's take a look here. Let's take a look here. Now, do we see that there's an easier option? I don't want to eliminate with the y's. I want to eliminate with the x's. Why am I saying that? Because they're opposites. They're already opposites. I'm not going to have to multiply by a negative if I want to do the x's. Would I have to do that with the y's? Yeah, they're both positive. So I would have to end up multiplying one of them by a negative. So if possible, try not to multiply by a negative. Okay, so I'm going to get these to be the same number. What number is that going to be, David? What's my LCM between 2 and 5? 10, right? I'm going to try to get these both to 10. What number am I going to multiply the top equation by? 2. What number am I going to multiply the bottom equation by? Good. You know, guys, just like, you know, getting common denominators a lot of the time, because that ties right into LCM. Like a lot of the times, aren't you just multiplying by like the other denominator? That's the same thing here. A lot of the times, you're just multiplying by like the other coefficient to try to make them match up. So the top equation becomes negative, now again, be careful, negative 10, positive 4, and did you catch it? Did you get the equals 64, or did you accidentally write 32 again? Because a lot of people would just write accidentally 32 again. Don't do that. Okay, we got 10x, positive 10x. On the bottom, we have a positive 15y, and then a 50. Be honest with yourself, did you accidentally write 10? Because that's a very common mistake, just to not multiply that last term. Okay, we add down now. We get a 19y is equal to 114. Oh, yikes, I hope 114 can be divided by 19. Oh, good. It does. Divide both sides by 19, and y is 6. Okay, going to the top or bottom? Which one? Bottom. So we say 2x plus 3 times 6 is equal to 10. 2x plus 18 is equal to 10. I subtract the 18 to both sides, and I get 2x is negative 8. And I divide by 2. X is negative 4. So my solution is negative 4, 6. There's my answer. Now, the only other layer that I could possibly add on to this is when they're not lined up, right? When they're not lined up. Guys, if they're not lined up, and I give you the option of doing whatever you want, like substitution, elimination, probably easier to do substitution if they're not lined up. Okay. All right, let's do one word problem. Trent buys 3 maple cream sticks and 4 glazed donuts for $6.75. Zach buys 5 maple cream sticks and 2 glazed donuts for $7.75. So if we know the total cost, can we figure out how much each type of donut costs? Yeah, we can. So try to set up your 2 equations. Set up an equation for Trent and set up an equation for Zach. Do it right now. Everybody write it out. See if you can figure them out. Set up an equation for Trent and then set up an equation for Zach. I think we know what our 2 unknowns are going to be. The maple and then the glazed. Let's make maple X and glazed Y. Okay, Trent's equation. 3x plus 4y is 675. Zach's equation. 5x plus 2y is 775. Okay. Do we see how solving using substitution here? Like if I wanted, does it tell you which method to use? Substitution, elimination, graphing? No. You can pick whatever you want. Would you all agree that substitution would not be the way to go? Like I've got decimals here. This is going to end up really messy if I try to solve for one of the equations. No, thank you. I think it's kind of a lot easier to solve by elimination. What would I multiply by to solve this by elimination? No?
Is it top by 5 and bottom by 3?
I could. Yes. I could, definitely. But there's an easier route to take. Like this.
The bottom by negative 2.
Yeah, you see, I could make the y's that the same by only multiplying by 1 of these 2 equations. I could just multiply the bottom equation by negative 2. Now, John, if you did that, you would probably not get it wrong, just as long as you did the math correctly. Top equation remains the same. 3x plus 4y is equal to 675. The bottom equation becomes negative 10x minus 4y is equal to, now I got to take 775 and times by negative 2. Negative 15 and a half. Now, when I add these 2 equations together, that gives me a negative 7x is equal to plus 675 negative 8.75. I divide by -7. Divide by -7. 1.25. Okay, now I know how much maple cream sticks cost. They cost $1.25. Let's see how much the glazed costs. Let's go back into my top. So that's $3.75 when I multiply 125 by 3. I subtract over the 375. And that gets me 4y is equal to $3, right? So and then I take $3 divided by 4 of them, 75 cents. Now don't leave them just like a coordinate here. They mean something. What's the cost for maple? Maple is $1.25. Glazed is 75 cents. Questions about that? Okay, let me hand out the worksheet that's for homework tonight. It looks like a lot, but I'm taking away 4 out of the 14 columns, so there's only going to be 10 on there. And some of them are already set up for you.
Oh, you literally have one. No, because you only need to multiply 5.
So there's just one?
Yeah.
I was really hoping they would say, no, it's not.
No, it's not.
The same one that is not.
Oh.
Like, I get a bunch in the morning, like, 2 in the morning, I figured like, 2 o'clock in the morning. Well, you actually.
No, that wasn't.
I would have dropped out. You would have told me you're right.
I can't hear what you're saying, but
You forgot to end the recording.
so long, everybody help.
I mean.